Hello everyone. Today we're going to make something very useful for a home network and a smart home. We'll set up ad and tracker blocking for all devices in the house at once. That means we won't install an ad blocker separately on every phone, laptop or TV. Instead, we'll set up our own local DNS server directly in Home Assistant using Technitium DNS Server and then configure the router so that all devices on the network use it. As a result, ads, trackers, analytics, and some junk domains will be blocked before they even reach your devices. This is especially convenient for smart TVs, set-top boxes, phones, tablets, and different smart devices where installing a regular uBlock is impossible. An important clarification right away: this is not a full replacement for uBlock Origin. For example, you won't be able to completely remove YouTube ads. Important clarification right away: this is not a full replacement for uBlock Origin. For example, you won't be able to this way because they often come from the same servers as the video itself. But banners, trackers, telemetry, and a lot of unnecessary network junk will already be filtered at the level of the entire home network. In this video, I'll show everything step by step: how to install Technitium DNS Server in Home Assistant, how to start it, what basic settings to configure, how to add block lists, and then how to set its DNS in the Xiaomi BE6500 router. At the end, we'll definitely check whether the blocking works and go through common mistakes that can cause beginners to lose internet access or prevent filtering from turning on. So if you have Home Assistant and want to make your home network cleaner and safer, let's get started. Before installation, a few words about why I chose Technitium DNS Server. First, it is an open-source project. In other words, this is not just some closed commercial service, but an open DNS server that you can run at home and control yourself. Technitium officially describes it as an open-source DNS server for self-hosting, privacy, and security. Second, it works locally inside our network. We don't install an ad blocker on every phone, TV, or laptop. We run one DNS server in Home Assistant, and then specify it in the router. After that, all devices in the house start going through it. The main advantage for us is blocking ads, trackers, and malicious domains at the DNS level. In Technitium, you can connect block lists of domains that need to be blocked. It's similar to Pi-hole, but with a more powerful DNS panel and more settings. In the official Docker description of Technitium, it directly mentions ad and malware blocking at the DNS level for the whole network. Another advantage is a convenient web panel. You don't need to configure everything through the terminal. We'll be able to open Technitium in the browser, see device requests, statistics, blocked domains, and manage block lists. And one more important point: Technitium can work with encrypted DNS requests, for example through DNS-over-HTTPS or DNS-over-TLS. That means further upstream, outside our network, it can send requests not in the usual open way, but through secure DNS servers. So our setup is simple. Home Assistant runs Technitium. Technitium filters DNS requests, and the router sends all home devices through this DNS server. Now we move on to installation in Home Assistant. Go to Settings, then open the Apps section. In older versions of Home Assistant, this section was called Add-ons, so if your interface looks a little different, look specifically for the App Store or Add-ons. Here we open the App Store and add a third-party repository. To do this, click the three dots in the upper right corner, select Repositories, and paste the link github.com/sterk-ha-addons/repository. Click Add and wait until the repository appears in the list. Now search for Technitium. We will see two options. For our task, choose exactly Technitium DNS Server Host Network. Why Host Network? Because the DNS server must be directly accessible to the whole home network. Later, the router will send DNS requests to the Home Assistant IP address, and Technitium must listen on the standard DNS port 53. Open the card, click Install, and wait for the installation to finish. After installation, enable Start on Boot. Watchdog. Start on Boot is needed so that Technitium starts automatically after Home Assistant reboots. Watchdog is needed so that Home Assistant monitors the app and restarts it if it suddenly stops. Enable Auto Update carefully. I would still update it manually. Now click Start, and we can add it to the sidebar, which I will do. After starting it, don't rush to change the router settings right away. First, open the Log tab and check that there are no errors. We are especially interested in errors related to port 53. If there are no errors, it means the DNS server started normally. In the documentation section, you can view a short guide and the capabilities of the add-on. It directly says that Technitium can be used as the main DNS server for the network, connected via the Home Assistant IP, secure DNS requests can be enabled, logs can be viewed, and unwanted domains can be blocked. But remember, this is a third-party add-on, so we change DNS settings carefully. Next, click Open Web UI. On the first login, the username is admin and the password is admin. After logging in, it's better to immediately change the password to your own so that nobody on your home network can access the DNS server settings. After the first login, we arrive at the main dashboard screen. Here Technitium shows DNS server statistics, how many requests there were, how many completed without errors, how many were blocked, how many clients connected, and which domains were requested most often. Right now everything is 0, and that's normal. We just installed the server, and the router is not yet sending DNS requests to it. In other words, Technitium is already running, but the home network is not yet using it. At the bottom there are top domains and top blocked domains blocks. Later, they will show the most popular domains and domains that were blocked. These tables are useful for checking whether filtering is working. Here Technitium shows a notification that a new DNS server version is available. But the important point is that we are using Technitium as an app inside Home Assistant, so we do not update it using the Ubuntu or Linux instructions from this window. This version should be updated through Home Assistant apps when an update appears in the App Store. So for now, we simply close this window and continue the setup. If later Home Assistant itself shows an update for Technitium DNS Server, then we update it like a regular Home Assistant app. Now open the Zones tab. This is where DNS zones are located. This is more about local domain names inside your network. By default, there are already several system zones here: localhost, 127.in-address.arpa, IPv6 zones, and other service records. Beginners do not need to touch them. They are needed for the normal internal operation of the DNS server. The Add Zone button is needed if we want to create our own local zone, for example home.lab. Then we can access devices not by IP addresses, but by nice names. The add-on documentation describes exactly this scenario. You can create a local DNS zone and add records for a NAS, printer, or other devices in the home network. But for our task of blocking ads and trackers, this section is not needed yet. So we don't change anything here, close the Add Zone window, and move on. The next tab is Cache. Here Technitium shows DNS records that it has already saved. Cache is needed to speed things up. If a device has already requested a domain address, Technitium can answer from its cache for some time instead of contacting an external DNS server every time. On the screen we see technical DNS records, for example for the root zone and the COM domain. Beginners do not need to change anything here. This is more of a diagnostic section where you can go if you need to check which DNS responses have already been saved. On the right there is a flush button. It clears the DNS cache. You should not click it for no reason. It is useful if you changed settings, added blocking, or some website opens incorrectly, and you need to force the DNS server to get fresh data. Here you can also see that requests go through cloudflare-dns.com/dns-query, which means DNS-over-HTTPS to Cloudflare is being used. Later, we can change the external DNS servers, but for now the main thing is to understand that Technitium can already receive responses and cache them. The next tab is Allowed. This is the list of allowed domains, or simply the whitelist. You add websites here that Technitium should not block, even if they accidentally end up in some block list. For example, if after enabling blocking, your banking app, smart home app, TV, or some website stops working, you can add the necessary domain here, and it will always be allowed. Right now the list is empty, and that's normal. At the start, you don't need to add anything here. First, we'll enable blocking, see what actually gets blocked, and only then, if needed, we'll add exceptions. The flush button here clears this list, so beginners should not touch it. The next tab is Blocked. This is the blacklist. Here you can manually add domains that Technitium should always block. For example, if we know a specific ad or tracker domain, we can enter it in the field on the left and click Block. After that, devices on the network will no longer be able to properly access this domain through our DNS server. But of course we are not going to manually add thousands of advertising domains. For that, block lists are used later. ready-made blocking lists that Technitium can automatically fetch and update. For now, we leave this section empty as well. It will be useful later if we want to block some specific domain manually. The import and export buttons are needed to load or save the list of blocked domains, and flush clears the list. So don't click it unless necessary. Now open the Apps tab. This is where additional modules for Technitium DNS Server are located. These are extensions for more advanced scenarios: a separate block page, extended blocking, DNS rebinding protection, log export, GeoDNS, failover, different DNS routing options, and so on. For our task of simple add and tracker blocking in the home network, we don't need to install anything here for now. Technitium can already work as a DNS server, cache requests, use secure DNS forwarders, and block unwanted domains through block lists without these apps. The app list really does contain modules like advanced blocking, block page, DNS rebinding protection, query logs, failover, geo-country, and others, but these are advanced features that are better left for a separate video. The only thing that may potentially be interesting later is advanced blocking, if we want to create different blocking lists for different devices, for example separately for the TV, for a child's tablet, and for a work computer. Now open the DNS Client tab. This is the built-in test DNS client. It is not needed for permanent configuration, but for testing. Can our Technitium DNS server correctly resolve domains, and what responses does it receive? For example, you can enter google.com here. Leave the query type as a, this is the regular IPv4 address of a website, and click Resolve. If DNS works, the response with IP addresses will appear below. Here you can also choose different DNS query types, A, Quad A, MX, TXT, Name, and others. Beginners usually only need A, which is an IPv4 address, Quad A, which is an IPv6 address, MX, which is mail servers, and TXT, which is service DNS records. On the right there is a DNS over selection. By default, UDP is selected. This is a regular standard DNS request. For our home network, this is exactly what is needed because the router and devices usually contact DNS through port 53 over UDP. There are also TCP, TLS, HTTPS, and QUIC options. These are secure or alternative methods for DNS requests. The add-on documentation says that Technitium supports regular DNS.do and DoQ, but by default port 53 is enabled for compatibility. For our basic scenario, nothing needs to be changed here. We can simply use this tab as a test, enter a domain, for example google.com, click Resolve, and make sure the DNS server responds in the log below. Now we move to the Settings tab. This is where the main DNS server settings are located, and inside there are several subsections: General, Web Service, Optional Protocols, Recursion, Cache, Blocking, Proxy and Forwarders, and Logging. I'll say right away, beginners do not need to touch most of the options. For our task, we mainly need three sections: General, Blocking, Proxy and Forwarders, Logging. The other sections are mostly for advanced scenarios. On the General tab, the main thing to check is that the DNS server is listening on port 53. Here we have the following values. This means that Technitium accepts DNS requests on the standard DNS port over both IPv4 and IPv6. For the host network version, this is exactly what we need. Later, the router will be able to send requests to the Home Assistant IP. The DNS server domain item can be left as Home Assistant. This is simply the name the DNS server uses to identify itself. Below there are different technical settings: TTL, IPv6, UDP socket pool, DNSSEC, DNS client subnet, and request limits. We do not change them for a basic home setup. I especially want to point out DNS client subnet. It's better not to enable it unless necessary, because it can pass part of your network information further to external DNS servers. We don't need this for home ad blocking. Also at the bottom there are important buttons: Save Settings, Flush Cache, Backup Settings, and Restore Settings. Before making serious changes, it's better to click Backup Settings and save a backup of the settings. DNS is an important part of the network, and if something is configured incorrectly, websites may stop opening. On this General tab, we don't change anything for now. We just check that port 53 is present. The next subsection is Web Service. These are not DNS settings, but settings for the Technitium web panel, meaning the interface we are currently working in. Here we can see that the web panel opens on port 5380. So if you open Technitium directly from a browser, the address will look something like this: Home Assistant IP address 5380. Below there are HTTPS settings. You can enable secure access to the web panel, specify a certificate, and set the HTTPS port. But for a home network and a basic setup, beginners don't need this right now. We are not publishing this panel to the internet. We are using it only inside the local network. The most important thing, do not expose this web panel to the internet. This is the administrative interface of the DNS server, and access to it should only be from your home network. We do not change anything on this screen. Leave port 5380 as it is. Don't enable HTTPS yet, and move on. The next section is optional protocols. This is where additional DNS protocols are enabled: DNS-over-TLS, DNS-over-HTTPS, DNS-over-QUIC, and other options. They are needed if you want devices to connect to your Technitium not through regular DNS requests, but through secure protocols. For our simple home setup, this is not needed yet. The router and most home devices will contact DNS in the usual way through port 53. The next section is TSIG. This is already an advanced setting for securing DNS zone exchange between servers. For example, if you have a primary DNS server and an additional backup DNS server, TSIG helps safely synchronize DNS records between them. For our home ad blocking task, this section is not needed. We don't add anything here and simply move on. The next section is recursion. This is where you configure who Technitium is allowed to resolve internet domains for. For a home network, the correct option is already selected: allow recursion only for private networks. This means DNS requests will only be served from our local network, not from the internet. This is safer because we are not turning our DNS server into a public open DNS. Below, we see that name minimization is enabled. We leave it enabled. This is an additional privacy setting for DNS requests. Beginners do not need to touch the other parameters: retries, timeout, and concurrency. Leave everything as it is and move on. The next section is cache. This is where DNS request caching is configured. Cache is needed for speed. If a device has already requested a domain, Technitium can answer from memory for some time instead of contacting the external DNS server every time. I can see that useful options are enabled: save cache to disk and enable serve stale. The first one saves the cache to disk when the DNS server restarts. The second one allows old DNS records to be temporarily served if the external DNS server is unavailable. For a home network, this is good. The internet will work more reliably. We leave the remaining TTL values and cache limits at their defaults. Beginners do not need to change anything here. Now we configure the most important section: blocking. Enable blocking. This is the main blocking switch. Leave allow TXT blocking report enabled. It is needed for technical reports about blocked domains. We do not touch the blocking bypass list field for now. Later, you can add the IP address of a device here for which blocking should not apply. In blocking type, leave NX domain recommended. This means that for a blocked domain, Technitium will answer as if the domain does not exist at all. For a home network, this is the simplest and most correct option. Below we have the allow/block list URLs field and the quick add drop-down list. Here you can choose ready-made blocking lists. For the first launch, I choose HGZ Multi-Normal All-Round Protection. This is a balanced list against ads, trackers, telemetry, phishing, and malicious domains. We don't choose aggressive options like Pro++, Ultimate, NSFW, Social, Gambling, and Porn for now. They can block more, but the chance of breaking something is also higher. After selecting the list, click Save Settings, then Update Now to download the block list immediately, and then flush cache so the new rules apply faster. At this point, basic blocking in Technitium is enabled. Next, we need to configure external DNS servers and then set the home assistant IP in the router. Now go to the proxy and forwarders section. At the top, we have the network proxy block. This is not ad blocking and not a VPN for all devices. This is a setting for Technitium itself, which proxy server it will use to go outside. For example, if you want to route DNS requests through an HTTP proxy, SOCKS5 proxy, a corporate proxy, or some separate gateway, Technitium really does support HTTP and SOCKS5 proxy for routing DNS traffic. For a regular home network, this is not needed, so we leave no proxy. But below that is the important forwarders block. Forwarders are external DNS servers that Technitium will contact if it does not know the answer itself. So the scheme is: device Technitium blocking check external DNS forwarder. Right now, Cloudflare is already configured here via DNS-over-HTTPS cloudflare-dns.com DNS query. DNS-over-HTTPS means that requests from Technitium to the external DNS go encrypted over HTTPS. Technitium officially supports DNS over TLS, DNS over HTTPS, and DNS over QUIC for forwarders. For our video, I would choose not AdGuard but Quad 9 Secure DNS over HTTPS. Why Quad 9? Because it is a public DNS service with additional protection against malicious and dangerous domains. Quad 9 itself says that it uses threat intelligence from different cybersecurity companies and blocks domains associated with malware and other threats. Important: Quad 9 does not block ads and trackers. It blocks dangerous websites and threats, not regular ads. Ads will be handled by Technitium through the Haguz block list, and Quad 9 will be an additional protective layer on top. Flush cache. Concurrent forwarding can remain enabled. Technitium will more quickly choose a working and fast DNS forwarder if there are several of them. The last subsection in settings is logging. This is where logs are configured, meaning what Technitium will write to a file. By default, file is selected. This is fine. Errors and service events will be saved to the log file. Below there is an important item: log all queries. It records absolutely all DNS requests from devices. This is useful for diagnostics. You can see which phone, TV, or app is contacting which domains. But I would not recommend keeping it enabled permanently, because logs can grow quickly and take up disk space. For a basic setup, leave it like this: file enabled, log all queries disabled, use local time can be enabled, max log file days 30 days or less. I would enable use local time so that the time in the logs is displayed in your time zone, not UTC. This makes it easier later to understand exactly when a device made requests. There is also a stats block here. This is statistics for the dashboard. It can be left at the default. If you enable in-memory stats, statistics will be stored only in memory, but after a restart, some data will be lost. For regular home use, this is not needed. Technitium can work not only as a DNS server, but also as a DHCP server, meaning it can hand out IP addresses to devices on the network. But in our setup, DHCP is already handled by the router, so we don't enable anything here. In a home network, there should usually be only one DHCP server. If you enable DHCP both on the router and in Technitium at the same time, conflicts may start. Devices may receive the wrong IP, gateway, or DNS. Next is the Administration tab. This is where Technitium administrative settings are located: active sessions, users, groups, permissions, and clustering. In the Sessions tab, you can see who is currently logged into the web panel, from which IP address, and through which browser. If you see an extra or suspicious session, you can terminate it. In the Users tab, you can manage users. For a home setup, one admin user is usually enough, but the main thing is that the password must be changed from the default. The Groups and Permissions tabs are used to configure groups and access rights. This is useful if several administrators use the DNS server, but for a home network, nothing needs to be changed. The Cluster tab is needed to combine multiple DNS servers into a cluster. For our setup with one home assistant, it is not used. Next is the Logs tab. There are two main sections here: View logs and query logs. View logs are the service logs of Technitium itself. Here you can view errors, server startup, blocklist updates, and other technical events. If something doesn't work, this is the first place to check. Query logs is the DNS request log. Here you can see which devices accessed which domains, what was allowed, and what was blocked. Before changing DNS on the router, I will first show what it looks like before Technitium is configured. For a clean experiment, I disable extensions like uBlock, AdGuard, VPN, and other filters. Otherwise, it won't be clear who is actually blocking the ads, the browser or our Technitium. Right now, the router is still working as usual. I have not changed DNS, and the home devices are not yet using our new DNS server. So I open a test website and show the normal situation: ads, banners, pop-up windows, push notifications, and advertising blocks load normally. For example, this test shows a very low blocking percentage. Some elements may be blocked by the browser itself, for example built-in pop-up protection, but the main ads and trackers still go through. This is an important point. Technitium is already installed and configured, but it is not yet participating in the network's operation. Until I set its IP address in the router as the DNS server, devices continue to use the regular DNS from the router or provider. So I record the before state: ads are present, tests show weak blocking, and Technitium does not yet have a normal flow of requests from home devices. Now we go to the router settings. Mine is a Xiaomi BE6500, but the logic will be similar on other routers. First, we need to find out the address of the router web panel. To do this, press Win+R on the keyboard. Type CMD and press Enter. Next, in the command prompt, type IP protocol configuration/all and press Enter again. Here we look for the line default gateway. Most often, this is the router address. In my case, it is 192.168.1.1. I copy this address, paste it into the browser, and open the router web panel. I enter the administrator password and go into the settings. Now I need the local network section. In the Xiaomi interface, this is commonly used settings and local area network setup. This is where the router's DHCP server is located. It is the one that hands out IP addresses to all devices in the home network. We need to specify which DNS server the router will give to devices. In the DNS1 field, I enter the IP address of my home assistant, where Technitium DNS Server is already running. For me, this IP is 192.168.1.186. I enter nothing in the DNS2 field and leave it empty. And this is an important point. Do not set 8.8.8.8, 1.1.1.1, or another public DNS as the second DNS. If you specify a second public DNS, some devices may start contacting it directly and bypass Technitium. Then ad blocking will work inconsistently. It will work in some places and not in others. If your router does not allow DNS2 to be left empty, it is better to enter the same home assistant address there, 192.168.1.186. After that, I click the Save Settings button. Before doing this, it is recommended that Home Assistant has a permanent IP address. If today Home Assistant has the address 192.168.1.186 and tomorrow the router gives it another address, DNS will stop working and websites on devices may stop opening. So it's better to reserve this IP for Home Assistant in the router settings in advance, or manually set a static IP in Home Assistant itself. After I save DNS in the router, the device needs to receive network settings again. Otherwise, Windows, a phone, or a TV may continue using the old DNS for some time. The easiest option is to turn Wi-Fi off and on. Disable and enable the network connection. Unplug and plug the network cable back in, or simply reboot the device. After that, the device will receive settings from the router again, and DNS should change to the IP of our Home Assistant. If you want to check this in Windows, open the command prompt and type IP protocol configuration/all. In your network adapter, look for the DNS server's line. It should show the Home Assistant IP. For me, it is 192.168.1.186. If DNS has not changed, you can force the settings to update with the commands IP protocol configuration/flushtons, IP protocol configuration/release, IP protocol configuration/renew. But for most users, simply reconnecting to Wi-Fi or rebooting the device is enough. And here is a very important point where many people may get stuck. I have already set the DNS server in the router and specified the IP of my Home Assistant where Technitium is running, but the ad test still shows that blocking is almost not working. Why does this happen? I open the command prompt and check which DNS my computer is actually using. Let's look up page add2.googlesyndication.com. And here we can see that the request is not going to my Home Assistant, but to an address like FE80. This is an IPv6 address. That means Windows receives DNS not only over IPv4, but also through IPv6. So we get this situation. Over IPv4, we have already specified Technitium, but over IPv6 the device can still contact the router or provider direct. As a result, some requests bypass our filter, and ad blocking becomes incomplete. To make sure Technitium itself works correctly, I do a second test by contacting it directly. Let's look up page add2.googlesyndication.com 192.168.1.186. Here, 192.168.1.186 is the IP of my Home Assistant. And here I already get the response non-existent domain. This means that Technitium really does block the advertising domain. So the problem is not Technitium, not the block list, and not Hagozi. The problem is exactly that the device is bypassing our DNS through IPv6. Therefore, for a simple home setup, I recommend this. If in the output of IP protocol configuration/all or lookup you see DNS servers like FE80 or other IPv6 addresses, and you did not configure IPv6 DNS separately, it is better to disable IPv6 on the router. On the Xiaomi router, this should be looked for in the Internet or Network Settings. The section may be called something like Internet Settings, Network Settings, IPv6. And here we set IPv6 disabled. After that, you need to refresh the network connection on the computer. The simplest option is to turn Wi-Fi off and on, disconnect and reconnect the network cable, or just reboot the device. You can also do this through the command prompt IP protocol configuration/flushtons, IP protocol configuration/release, IP protocol configuration/renew. After that, I check again, and look up page add2.googlesyndication.com. Now, at the beginning of the response, the DNS server should no longer be the router's IPv6 address, but the Home Assistant IP, 192.168.1.186. And if everything is configured correctly, the advertising domain should not open, and the response should be something like non-existent domain or next domain. This is the sign that blocking is working. It is also important to configure the router itself so that it takes DNS from our server and does not use the provider's DNS servers. In other words, we route everything through our DNS filter. On Xiaomi, in the DNS Settings tab under Internet Settings, select Manually Configure DNS, enter our IP 192.168.1.186 and click Apply. After fixing DNS, I open the test websites again. In one test, we can already see around 96% blocking, and in another around 80%. This is a normal result for DNS filtering. But it is important to understand that different websites test different things. Some test specifically advertising and tracking domains. Technitium handles these well. Others additionally check pop-up windows, push notifications, cosmetic banners, scripts, and page elements. A DNS server cannot fully remove those, because it does not see the HTML page, it only works at the domain level. So if an ad loads from a separate advertising domain, Technitium will block it. If a banner is built directly into the website or is an element of the page itself, then for that you already need a browser blocker, for example uBlock Origin. Let's check DNS one more time. You can see for yourself that the server here is Home Assistant and run the ad blocking test. You can see the difference yourself, how it was before using Technitium and how it became with it. At this point, the basic setup is complete. And as you can see from the tests, ads are indeed blocked very well by our local DNS service. Today, we installed Technitium DNS Server in Home Assistant, enabled domain blocking, added filtering lists, configured an external DNS forwarder, and set the Home Assistant IP address in the Xiaomi router as the main DNS for the entire home network. And most importantly, all of this works centrally. You don't need to install a separate blocker on every phone, TV, set-top box, or computer. You configure DNS in the router once, and all devices on the network start going through our filter. Plus, this solution is free. We use Home Assistant, Technitium DNS Server, and open block lists. As a result, we get our own local DNS filter that blocks advertising domains, trackers, analytics, and some junk requests before they even load on the device. But an important point, this is still not a full replacement for uBlock. A DNS filter blocks domains, but it cannot cut out banners that are already embedded directly into the page. It does not remove cosmetic website elements and does not guarantee YouTube ad blocking. So the ideal scheme is this: Technitium for the whole network, and uBlock Origin additionally in the browser. We also separately covered the IPv6 problem. If blocking does not work after configuring DNS, make sure to check with and look up which DNS is actually being used. If you see IPv6 addresses like FE80, the device may be bypassing Technitium. In this case, you either need to configure IPv6 DNS correctly or, for a simple home setup, disable IPv6 on the router. One more piece of advice: for such a setup, it is better to have proper hardware for Home Assistant. The DNS server will serve the entire home network, so how quickly websites open and how stable the internet works depends on the stability of your mini PC or server. I will leave a link to my smart home server in the video description. I have already made a review of it, that link will be there too. In the end, we did it. We made free ad blocking at the level of the entire home network. Phones, computers, TVs, set-top boxes, and smart devices can now use one shared DNS filter through Home Assistant and Technitium DNS. I will leave links to Technitium, the block lists, my smart home server, the server review, and useful commands in the description. I'll also add links to my social media and Telegram group, where I publish news, smart home posts, useful devices, and various interesting finds. If the video was useful, hit the like button, subscribe to the channel, and write in the comments which block lists you use and what result you got after the setup. That's it. Thank you all for watching. Peaceful skies and kindness to everyone. See you in the next videos. Bye bye.